In this video, we're going to look at finding features of quadratics. And the first thing we're going to look at is trying to determine the direction of opening for the parabola that would be graphed. And in order to do so, we would have to look at the equation written in its standard form. So ax squared plus bx plus c. And the way we tell the direction of opening is we look at the coefficient of the squared term, so in this case a. If a is negative, meaning less than 0, it's going to open down. If a is greater than 0, it's going to open up. Now, if it opens downward, what that means is you can expect the parabola is going to be in-shaped. And if it opens upward, the parabola is going to make a U. And as we do these, I'm going to put the graph of them over here on the right-hand side with Desmos, so that way we can see it graphically. So if I look here at the first problem, and I want to know what is the direction of opening for negative x squared plus 6x minus 6. Well, I look at the squared term at its coefficient. Since that number is negative, this is number 1, it's going to open down. And if I look at the graph over here on the right-hand side for number 1, I see the parabola there, and it makes an N shape, and the opening is downward for the first one. Then we come on over here to number 2. And same thing, I want to know what is the direction of opening. I go find the square term, look at its coefficient. In this case, the coefficient is 2. Since 2 is greater than 1, it's going to open up. So it opens upward. Meaning graphically, if I looked at number 2, it should make a U shape. So I put the graph of number 2 over here on the right-hand side, and I see in Desmos that it makes a U shape, meaning it opens upward. Now let's go try to find the zeros and the y-intercept. Now zeros is just another word for finding the x-intercepts of a function. And we're going to do this by hand and confirm our answers by looking at the graph of it. And we'll start by finding the x-intercepts. To find the x-intercepts, what we're going to do is we're going to try to factor. So try to factor first. And so I look here and say, okay, I'm going to make y 0. So I'll put in 0 for y. And then we're trying to solve this quadratic expression here. So if I'm looking at this and say, well, the right-hand side, the first thing I could do is I could pull out a negative. And if by doing that, it's going to make negative 1 times x squared minus 6x plus 5. And then we would go try to factor that trinomial a little farther. So I have negative 1 times, and we'll see if that should factor. So the two numbers that multiply together to make negative 5, or excuse me, make positive 5, that add together to be negative 1 would be negative 1 and negative 5. Now from here, we're going to set the individual factors equal to 0. So I have x equals 1 and x equals 5. Now, those are my x-intercepts. So my x-intercepts for this graph are at 1, 0, and 5, 0. We're going to write our intercepts as coordinates, not as just x equal and a value. We got to write them as coordinates. Now, the y-intercept, to find it, what you're going to do to find your y-intercept is we're going to make x a 0 and solve for y. And so I put in 0 for all the x's. So we have y equals negative 1 times 0 squared plus 6 times 0 minus 5. And it leaves me with y equals negative 5. So the coordinate of the y-intercept would be 0, negative 5. And we'll look at this graph over here on the right-hand side graphically. And I want to know, where does it cross the coordinate axis? So the x-intercepts, 1, 0, 5, 0. We got both of those. And the y-intercept, 0, negative 5. So we found them by hand and confirmed with Desmos. All right, let's do another one. All right, so I'm looking here at number 4. I want to do the same thing. I want to find my x-intercepts and my y-intercepts. So my x-intercepts, I'm going to go through that first. We're going to make y 0 and solve for x. So 0 equals x squared plus 2x minus 3. And then we try to work the factor from there. So the two numbers, I have x and x, the two numbers that multiply together to be negative 3 that add up to be positive 2 in the middle would be positive 3 and negative 1. And then we would set those equal and solve for x, set them equal to 0 and solve for x. So I get x equals negative 3 and I get x equals positive 1. So my x-intercepts for this graph should be at the coordinate negative 3, 0 and 1, 0. Now to get the y-intercept, what we're going to do is we're going to make all x's 0 and evaluate for y. So we'll have y equals, that'd be 0 squared plus 2 times 0 minus 3, and that leaves me with y equals negative 3. So our y-intercept as a coordinate would be 0, negative 3, and let's confirm that by looking at its graph. And so I pull up the graph here on the right-hand side of number 4, and I'm going to click on the intercept. So we have an intercept at negative 3, 0, an x-intercept at 1, 0, and a y-intercept at 0, negative 3. All right, let's go on to number 5. And so I'm looking here at number 5 and say, all right, let's start by trying to find our x-intercepts again. So x-intercepts. We're going to make y equal to 0, and we're going to try to solve for x. So I got 0 equals x squared plus 2x plus 4. And then we look to try to factor this. And so if I start this process of trying to factor it, the two numbers that multiply together to make positive 4 but add up to be 2, well, my options are 1 and 4 and 2 and 2. Well, neither one of those combinations will work, so it's not. I can't factor. So cannot factor. So what we do is we got to go to plan B. So let's try the quadratic formula. So the quadratic formula would be your solutions for x, if I set this problem equal to 0, would be negative b plus or minus the square root of b squared minus 4ac all over 2 times a. And we start putting values in for these constants, and we have negative 2 plus or minus the square root of 2 squared minus 4 times 1 times 4 all over 2 times 1. And when we were doing these, when solving, what I recommended was figure out what's up underneath the square root first. What are you actually taking the square root of? And so we have 4 minus 16 up underneath that square root, so square root of negative 12 all over 2. Well, that raises an issue because we're trying to take the square root of a number less than 0, and so that produces non-real answers. So because I can't solve this part and get a real answer, what this means is we have no solutions. Now, back in context of an x-intercept, this graph actually has no x-intercept because we could not solve and get a real answer. Now, not all graphs of parabolas have to have x-intercepts. They will all have y-intercepts, though, because I can put in any number I want to for x, and it'll give me a y. So y-intercept now, we're going to make x equals 0, solve for or evaluate for y. So y equals 0 squared plus 2 times 0 plus 4, and we get y is equal to 4. So our y-intercept is at the coordinate 0, 4. So let's look at what's going on here graphically. So I pull up the graph here of number 5, and I look, and I see this parabola. It opens upward, but it does not cross the x-axis anywhere, and it crosses the y-axis at 4. All right, let's go to number 6. So this next problem set here when trying to find features of quadratics is we want to look to try to find the axis of symmetry and the coordinate of the vertex. Well, The axis of symmetry. What it comes down to is we have our equation of a quadratic written in standard form. So y equals ax squared plus bx plus c. The axis of symmetry is a line that splits this parabola right down the center, and we'll look at that here in a second. And it's a vertical line for the ones that we work with here in Algebra 1. And to find the axis of symmetry, what we do is the x value of this vertical line is going to equal negative b divided by 2 times a. And so that's going to be the line that will split the parabola right in half, right down the middle. So before we even worry about finding the coordinates of the vertex, let's just find the axis of symmetry here in number 6. So here in number 6, I'm going to say, all right, my axis of symmetry, I'm just going to write axis, is going to equal, so I have x equals negative b divided by 2 times a. Well, so that's going to give me, so negative 8 over 2 times 1. And that gives me x equals 4. And so what that means is the line x equals 4 should split the parabola right down the middle. So let me pull up the graph here, number 6. And I see the parabola and the way it goes. And so I'm going to add another equation to this. And I'm going to graph the line x equals 4. And you look at this, and so I hide my equations here. That line splits that parabola right down the middle. That's why it's called the axis of symmetry. Now, to find the coordinate of the vertex, so the vertex is the maximum or the minimum, it's the bending part of the parabola, is what you do to find the vertex is the vertex will have a coordinate that is your axis of symmetry. It'd have an x value of the axis of symmetry, and then you just would evaluate the y. So you plug in the axis of symmetry into the x's and evaluate y to get the y value of the coordinate. So if I'm looking at my axis of symmetry being 4, I'm going to go back in. So to find my vertex, we're going to have y equals, I got to get its y value because I know the x value of this thing is 4. So it'd be 4 squared minus 8 times 4 plus 13. And I evaluate that side, then it's going to give me the y value of this vertex. And we get a y value to be negative 3. And so our vertex has the coordinates 4, negative 3. So that should be where the bending point is for this parabola. And so I'm going to go back here to my parabola. I'm going to get my axis. Actually, I'll leave my axis of symmetry there. And I want to see what the coordinate is of that bending point. And it's at 4, negative 3. Now we call that bend, this vertex. We can classify it as 2 ways. It can be considered a minimum or a maximum. Since that bending point, that vertex, is at the absolute bottom of the parabola, we're going to call it a minimum. So I'm going to write it's a min. So our vertex is at 4, negative 3. And we call it a minimum. All right, one more. Let's look at here at number 7. So here in number 7, I want to find the axis of symmetry and use it to determine the vertex. So the axis of symmetry for this, it's a vertical line, so it would be x equals negative b divided by 2 times a. So I put in the values for these constants. So b is negative 8, a in this case is negative 2. And we work through here, and that'll give us 8 divided by negative 4. So our axis of symmetry is at x equals negative 2. So let me pull up the graph of number 7. Let's make sure that x equals negative 2. We'll split this parabola right down the center. And so let me graph x equals negative 2. And pull this out of the way, and I look, it splits that graph right down the center, so therefore we did it correctly. And now to find the vertex. So the vertex here, I'm going to take that x value, I'm going to put it in for all of the x's. All right, so I have -2, leave myself some room, so I'm going to make, and I'm putting in -2 for all of the x's here. And then I'm going to evaluate to get the y value. So we evaluate that expression there to get y, and we should get y to be equal to 4. Now, our vertex we write as a coordinate. It's going to be the x value of the axis of symmetry by the y value we got when we plugged that axis of symmetry x value into the equation. So there is my vertex at -2, 4, and it's going to be considered a maximum because when I look at the graph, it's open downward. Anytime a graph opens downward, the vertex is going to be a maximum. But you can also see this graphically is that coordinate -2, 4 is at the absolute top